Hello everyone, welcome to this video on decision tree algorithm. Decision tree is one of the most celebrated algorithms in the realm of machine learning because of its wide range of applications in various fields. The next part of this video will share a snapshot view about what we'll be discovering in this video and subsequent videos. First, we will start with sharing a brief overview about decision trees and various aspects of the decision tree algorithms. We will cover very important theoretical aspects of different types of algorithms, their working logic, pros and cons of various techniques as well. We will also discuss about their real-life applications. Then, we will move on with a case study using employee attrition data and apply decision tree algorithm to solve the associated problem at hand. We will also cover some key technical aspects like hyperparameter tuning, model validation using decile report, dealing with class imbalance in your data, and finally, we'll demonstrate the way to visualize the decision tree. Introduction to decision tree. A decision tree is an acyclic graph that can be used to make business decisions. In each branching node of the graph, a specific feature, let's say J, of the feature space is examined. If the value of the feature is below a specific threshold, then the left branch is followed, otherwise the right branch is followed. As the leaf node is reached, the decision tree is made about the class to which the example belongs. In this part of this video, we'll discuss about tree-based methods for both regression and classification problems. This involves stratifying or segmenting the predictor space into a number of simple regions. Since the set of splitting rules used to segment the predictor space can be summarized in a tree-like structure, these types of approaches are known as decision tree methods. It's a form of supervised machine learning which typically deals with label data like what you have already seen for other supervised methods like linear regression or logistic regression. Decision trees are very powerful and popular for both classification and regression problems. The attractiveness of tree-based methods is due largely to the fact that decision tree represents rules that can be readily expressed in English so that we humans can understand them well. Decision trees are also useful for exploring data to gain insights into the relationship of a large number of candidate input variables to a target variables. Decision tree model is typically a non-parametric in nature, like KNN or linear SVM. Another salient feature of this algorithm is that decision trees are also used for feature selection in large datasets, and they can tackle the problem related to data with missing observations. Let's deep dive a bit more and learn about how decision tree models are built. At a very high level, any decision tree algorithm follows 4 major steps as are highlighted in this part. Step 1 involves starting with a dataset and with some relevant input features along with the target variable we want to model. Step 2 focuses on the logic of finding the best feature to split the data. We will talk about different metrics or identification criteria to find the best feature in detail in later part of this video. At step 3, the data is split into smaller segments that contain possible values of the identified best features. At the end of the step, a node of a tree is found which increases the purity or reduces the variance. At step 4, this step ensures the process continues recursively and generates new nodes by using the segment found in the previous step. The process continues till the algorithm achieves maximum possible accuracy in classification or minimum variance for the regression. One noticeable element of any decision tree algorithm is that they are capable of unearthing nonlinear relationship within your data, meaning the decision boundary between target variable classes is nonlinear. Now, let's have a look at the fully grown tree. As you can see, a fully grown tree will have different components like root node. It is the space where the decision tree algorithm starts off. Then it reaches different decision nodes based on their splitting criteria. We will talk about different types of metrics for arriving at the best feature which can ensure the split. Then the last component is terminal node, beyond which a tree will not grow based on certain key specified metrics. We will talk about in each of this part in greater detail in the following videos.